Blockchain is a possibility to do B2B integration, but it's just one out of 3 approaches to do this. I will explain how that works. If we want to do B2B integration between stakeholders in a process, between market participants, there are different ways to do that. And traditionally, there are 2 ways that we find out there in the world. One is communication directly between the participants, which is point-to-point communication or one-to-one communication. If anyone has to send data to a market participant, to a business partner, a message is sent over the internet. It might be encrypted, it might be authenticated, and then sooner or later the market partner responds or whatever the process requires. Yeah? Think of the telecom sector where supplier switching needs to be organized between the telecom operators, or think of the same process in the energy space. If you change your supplier of electricity, you want to switch from the old supplier to a new supplier, then these have to talk to each other, they send data to each other, and there's a third party, which is the grid operator, who is also part of the process. So everyone sends data directly to one other market participants, because there are probably hundreds of other grid operators and also hundreds of other suppliers. Yeah? But just these 3 directly send data, and the others are not involved in the process. They don't see anything from the process because it's right over the internet. The other way to do that is to use a platform, a third party. Yeah? Think of Uber or Airbnb or Swift, and you send the data to this third party. The third party forwards the data to the receiver. In some cases, the party, of course, adds local logic and organizes the process. Yeah? It's coordinated by the third party. That's the 2 classical ways, and the third one is blockchain. And the next slides just show this. Here we have the third party coordinating the process. It's easy because the market participants or the process participants, they just use an API of this third party. Yeah? You use an Uber API or you use an Amazon API, and everyone does that. And if you use the API in an incorrect way, Amazon will tell you that you cannot participate. Yeah? It's a technical rejection then. That makes standardization quite easy because it's just that one third party who sets the standard. Amazon says, this is my API, take it or stay away from participating in my process. And they are happy because there is no potential for misunderstanding. There is no single one, if he misbehaves, that single one drags also the others into process issues because this one is not compliant with the standard. But there's also a disadvantage because this is a monopolist. Yeah? Amazon is a monopolist, Airbnb is a monopolist, Uber is a monopolist, exchanges are monopolists. And if this monopoly is exploited, then of course we have a high profit margin here on the third party side. And then they may get nervous and they may think about finding a different solution to this. The second approach, as I said, is the direct data exchange. I mentioned that already. The main characteristics is we don't have any third party. So we don't have any likelihood that there will be a third party monopoly. So the transaction costs are lower. It is the consortium which needs to define the standard. It's not the third party who sets the standard. And that is also where the issue is. Yeah? They need to agree. If they are competitors, it's sometimes not very easy to agree, if not impossible. And there are, well, some cases where this is easy. For example, in the energy sector, because the energy sector is strongly regulated, and the regulator and the legislator requires standardization between the market participants. So there is some regulatory pressure which helps achieving standardization. But if you look at the logistics sector, which is not very much standardized. They are fierce competitors, and they just don't talk to each other. And it's very difficult to find an agreement with them on a standard. And that is exactly the disadvantage, because this approach of having everyone talking to everyone else requires an agreement and a true standard which covers data formats, communication protocols, and the business process itself. Yeah? So this is the other classical way. It works in some cases. We are also involved in a project called EDA, which stands for Energy Data Exchange in Austria, which is a very complete standardization of these three aspects. But it's a rare case. Yeah? It's obviously very difficult in other sectors than the energy sector. And then there's blockchain as the third way to do it. We use nodes, which don't need to be thousands of nodes. It could be 10 or 7 or 6. And these nodes doesn't cost much. It's a low-cost infrastructure. Virtual machines are used from Amazon or Microsoft Azure. And they cost 20 euro a month or 50 euro a month. And we can achieve something which comes close to 100% availability at a very low cost of operation. That is already a specific advantage. High availability, low cost. And if the blockchain can only be accessed by communicating with the nodes of the blockchain, and if the nodes offer an API, this API drives already the participants in the way how they exchange data. And this logic behind the API can also reject wrong data. Yeah? So we have a combination here of the first and the second case. We don't have a centralization, so this is a little bit like sharing data directly between the participants or exchanging data between the participants. But we don't have the standardization issue. And it's also a little bit like a third party, because the blockchain offers an API, but it's not one third party. It is a set of operators. And in the best case, these node operators are part of the consortium. So it could be 10 out of the 100 participants in the market. And it's very important to ensure that these 10 don't have an advantage of operating the nodes. Yeah? So whatever data goes through these nodes in this sphere, which is shared by all participants, this data must be in a format which doesn't allow the node operators to gather more information than the non-node operators. Yeah? So if there's anything commercially critical, it should be encrypted at the application level such that node operators doesn't see that data. However, if too much is encrypted, it's not really helpful, because then the data cannot be processed by anyone else. It's always a challenge to encrypt only a part of the data which is commercially relevant, and other data which might also be commercially relevant, but which can be shared with the rest of the participants, that should not be encrypted, because then they can build their local processes on exactly that data. An example is a distributed exchange. Yeah? So if an order is sent through the blockchain, and the order says, I want to sell a share of IBM, and the price is, I don't know, I just say 60, and I sell one share, then the price and the ISIN number should be published, yeah, should be visible to everyone. But who sent the order? My identity should be encrypted. Yeah? And then it works. Then the others see the order in the market, they receive this, they can evaluate if they want to buy my IBM share or not. And then they can send an execution message. Yeah? If my name, my identity would be visible to everyone, no one would send an order, because this would disclose too much information about my financial situation, possibly, or of a market participant. Yeah? So that would commercially not be viable. So as the blockchain is a store of transactions which are exchanged or shared between the market participants, they are just stored in the nodes. They are possibly sent by the left party as a new transaction to the node where the party is connected to. And then as a next step, this new transaction is distributed across the network, across the 10 nodes, which are the validators in this setup. And the new transaction is stored there in the memory, if you like, of each node, which is also called the mempool. Yeah? And then when the block time is over, when the deadline kicks in for finalizing a block, there will be one out of these nodes who takes the proposer role. And the proposer could be any one of them. Yeah? It would be a daisy chain mechanism or a round-robin mechanism. So after this guy has been the proposer, this is the next one, then comes this one, and so on. Yeah? So everyone plays the role of the proposer at a certain point in time for a given block. Now for the current block we are talking about, which is to be finalized, this one is the proposer, and he asks the remaining 5, this is my proposed new block based on the transaction which have been collected over the past block time. Are you happy with that? Yeah? Would you agree with that? And they say, yes, we agree, because they are all based on the same logic. That is a multi-round process. It's abbreviated here. But finally, if the new block is agreed, every of the validating nodes sends out this new block to the applications which are connected to the node. And maybe also to other nodes who are non-validator nodes. And that's it. Yeah? So every block time, a new block is created. And the effect is that this transaction, which has been sent here by the left one, is distributed to everyone else after the block has been created. One may say that it could also be distributed during the block time. Yeah? So it's originally submitted by the left application to this node. It is immediately shared with the others. And why not immediately push up this information to the participants? That might make sense in certain cases. But if we use blockchain, one blockchain feature is double spending detection. And we could not detect double spending if we do that intra-block. Yeah? We can only detect that when the block is finalized and when the decision is made which transaction to include in the block and which not. So let's say this guy sends a transfer of a value to this party here, and then he sends another transaction which transfers exactly the same value to a third party. So that would be a conflict. Yeah? That would violate the overall consistency of the data in the blockchain. And if it is immediately forwarded, it's already executed as a transaction. And at block time, we could detect that 2 conflicting transactions are within the same block, and we could select one which is accepted and the other is rejected, but it's already too late because the message has already received the application sphere. That is the reason why this should wait until the block has been finalized. Then validation means keeping up the consistency of the assets, and only if consistency could be assured or if inconsistent transactions are rejected and don't end up in the block, then the final data, the final result is shared with the applications. That's the way how blockchain communication works, and this is, by the way, why we reduced our block time in the environment that we are using, which is Tendermint in connection with the wormhole framework that we developed ourselves. Why we use a blockchain of only 1 second? Because we can drive down exactly this point in time where the transactions which have accumulated in the blockchain within a second could be shared with the remaining applications. That is very fast for blockchain terms, but it's still slow compared to exchanges. Yeah? Which means that this mechanism cannot be used for high-frequency trading, for example, where we have transactions being executed within microseconds, and the applications want their feedback within milliseconds. But there are many markets out there in the world which are not very liquid and which have a transaction rate of maybe a transaction every 5 seconds. And such markets don't really require microseconds or milliseconds performance, but this approach is perfectly suitable for such markets. Yeah? So it's again in the sense of the elevator slide that I showed in a different video, it's very important to understand where are we? What is our business model? Are we talking about high-frequency markets or do we talk about low-frequency markets, low liquidity? If it is low liquidity, blockchain makes sense. In the other case, not. So that is where blockchain could apply. Less liquid markets, and then the block is just added to the blockchain by each of the nodes. And then there is another application of blockchain. So far we haven't talked about token currencies or tokens or the management of assets. But what we can add then to the blockchain as a carrier, as a physical layer, is accounts. Yeah? So if we identify the participants in a pseudonymous or using their real IDs, we can book between accounts. Yeah? Everyone has an account, and if a transaction is executed, like an exchange transaction, for example, and if the good has a value of €1, the value of €1 could be booked from this person's account to that person's account, or this participant to that participant. And the good thing is, it mitigates the counterparty risk. Yeah? Because if this one here is a seller, and if he sells 1,000 goods per day at a price of €10, the risk is €10,000. And if this is paid on the next day, several of the counterparties go bankrupt or default, he will not receive his payment. What we can do with blockchain is to connect the payment transaction right with a commodity transaction, which means that it is instantaneously settled, and the risk is zero for the seller. If the buyer doesn't have any money on his account and is not able to pay, the transaction would be rejected by the validators. Yeah? It's a part of the validation criteria. And that makes blockchain an interesting environment for such processes like distributed marketplaces. This is why distributed marketplaces are a typical blockchain candidate as a business process. And this is how the coins flow. Yeah? That's it.